So why would you want to have the formula in this way? Well, if we imagine the equation was just x plus 4, if it was just x plus 4 all squared is equal to 0, well, what would be the what can you say about that equation there? So this equation here would have only one solution, because normally, most of the time, you would try to solve a quadratic, and you'd end up something like maybe x plus 4 multiplied by x minus 5, perhaps, right? And that would be equal to 0. And so what this would mean is either all of this is equal to 0, or all of this is equal to 0. Because when you multiply them together, it equals to 0, then one of those things must equal to 0. Otherwise, there's no other way of the two of them multiplied together being equal to 0. So this would lead to the solution of x is either equal to minus 4 or x is equal to 5, right? Now, in this case over here, what you've got is this. You've got two identical, right? So x plus 4 multiplied by x plus 4, which means you've got one solution, and x would be equal to minus 4. Now, if you imagine what that would look like as a graph, which it doesn't need to be there. So yeah, we've got, so in this situation, there'd be one solution. So how would this look graphically? Well, if it had two solutions as a graph, you might have something like this, right? So you make over here, this would be one of the solutions, and over here, this would be the other solution. If you've got only one solution, then this would be that it would just touch the axes once, like over here. So in this case, that would be minus 4, right? So so if you have this kind of thing, it means that's minus 4. Now, what this is saying is x plus 4 all squared plus 2. So it's just like the x plus 4 all squared, but it's 4, but you've added 2 onto that. So in other words, it's just a little bit higher. So that sort of minimum point, which can be thought of as the turning point, would be that way on the x-axis, but it would be 2 on the y-axis. Okay, and also this means in this particular case there is no solution to the problem because it doesn't actually intersect the x-axis. So if I said all of this is equal to 0, solve the problem, you wouldn't be able to, because it never does equal to 0, right? So if it wasn't the case, however, if it did equal to 0, then, for example, if it ended up being, if I ended up it being something like x plus 4 all squared minus 2, then instead of it being the minimum point being at plus 2, it would be minus 2. So it would look like this. So then now it's going to be below, and in this situation you'd have the that would be minus 2, and now it would have a solution, right? So this point here would be the solution if it was equal to 0, right? And incidentally, you'd also have a point at which it crossed the y-axis, and this would be, in this case, 18. So when x is equal to 0, then y would be equal to 18. So this is the reason why you would so the advantage of completing the square is it means you can do that. You can find the minimum point. You can just do more with it. You can still solve it. You can find out if it's possible to solve for a start, and you can solve it. You can also solve it if the answer ends up being a surd. So if the answer is square root of 2 or square root of 2 over 3 or something like this, then it is possible to solve that, which you wouldn't be able to use the regular method to do that. Okay, so we're going to have a quick look at the general method about how. Okay, so that's just some of the advantages of why you might complete the square. Okay,